Okay, 4.8 is a lot easier to explain and to grasp than 4.7. 4.7 didn't have anything all that difficult, especially if you understand the unit circle and what your trig functions do. But 4.8 is a lot easier to follow. So what's going to happen is we're going to solve right triangles. We're going to find all of the pieces. Up to this point, we've been able to find all the sides. We haven't known how to find angles. But now we know how to find angles because we know we can use inverse trig functions. And then we're going to do some application problems, some word problems, where we're going to do one just to remind you what we did in the beginning of chapter 4, and then we're going to do one where we're looking for an angle. Okay, so to start with, we just have this. They give you the picture of the triangle, and they give you some information, and they want you to find everything else. All right, so let's label what we know. They told me that side A is 14.3 and side B is 19.2. I remember that sides are opposite the angle that has the same name. All right, so to find side C, we can just use the Pythagorean theorem. So we'll start with that. To find side C, we can just use the fact that we know this squared plus this squared will give us c squared. So we know c is the square root of this. And I'm doing this to save myself a little bit of time and some writing, and I can type it all on my calculator at one time. If I do the square root of 14.3 squared plus 19.2 squared, we get that c is 23.9. All right, so now we know angle C is 90. We just need to find angles A and B. All right, we have to use trig to find one of those, and then we can subtract from 180 to find the other. All right, so to find angle, you can pick A or B. I pick B. All right, so to find angle B, we're going to use tangent because we know opposite and adjacent. Now, we just figured this out, but that was not given information. And it's a good idea to always use given information when you're finding things, because if you make a mistake and then you use that number, then now you've made two mistakes. All right, so we're going to use tangent because from angle B, we know opposite and adjacent. So we're going to say 19.2 over 14.3. Now pay attention, make sure that you mark things and you think opposite and adjacent, because it's important. Otherwise, you're going to tell me you found B, but you really found A. All right, so we learned yesterday that we have to take the inverse tangent of both sides. Well, instead of showing that over and over again, I'm just going to start saying I know that angle B is equal to the inverse tangent of this fraction. So in my calculator, I'll do second tangent and then 19.2 divided by 14.3, and I get 53.3. All right, I am back in degrees, right? Yes. Okay. So to find angle A, all we have to do is do 180. Or actually, we could just do 90, but we'll do 180 minus that 90-degree right angle for angle C, minus 53.3 that we just got for angle B. And we get 36.7 degrees. So now you know everything about that triangle. All right. So number 2, let's say we are given angle P is 35 degrees and R is 14. And they give us a slightly different looking triangle. It's still a right triangle, but they gave it to us all kinds of weird. And they didn't label it A, B, and C. All right, so we know that this is 35 degrees, and we know that this is 14. All right, so I don't have enough to use Pythagorean theorem. I have an angle and I have a side. So from this angle, I know the hypotenuse. So I can use sine to figure out side P. So I can say sine of 35 degrees, so this angle, sign is going to be opposite over hypotenuse, so side P over 14. My variable's on top, so I just multiply. So P is going to be 14 sine 35. So type that in your calculator. And you get that P is about 8.03. So to the nearest tenth, that's just 8.0. All right. So again, instead of using that found information in the Pythagorean theorem, I'm going to go ahead and use cosine of 35 degrees. And so now we're doing adjacent over hypotenuse, so Q over 14. So we can say that Q is equal to 14 cosine 35 degrees. So in my calculator, we're going to do 14 cosine 35. We're not looking for an angle, we know the angle, so we do regular cosine because we're plugging in an angle. We get 11.5. All right, when I'm looking for an angle, that's the only time I do an inverse. All right, but on this one, I don't have to use that to find that missing angle. I can just use the fact that I know that a triangle adds up to 180. I'm also on this one going to understand that this is going to always be 90, so I'm just going to say 90 minus 35, and that gives me a 55-degree angle for angle Q. All right, one more where we're actually looking for the angle. I want you to try this one on your own, so pause the video, work it out, and then see how you do. All right, so they give us a normal looking triangle again. And it's going to be, these are the strangest letters, J, R, and G. Usually they label them with letters that make sense, like they're in a row. All right, try this one. So pause the video, try this one, and then unpause and see how you do. All right, so we know that this hypotenuse is 17, and we know that this side is 12. So I can figure out side G by doing the Pythagorean theorem. So 12 squared plus G squared equals 17 squared. So I'm going to move the 12 over here, and then take the square root of both sides. So square root of 17 squared minus 12 squared gives me that side G is 12.04, so just 12.0, since it told me to the nearest tenth. All right, so now I need to find one of my angles using trig. I'm going to pick J. All right, so J, we know opposite and hypotenuse, so we're going to do sine. Now, don't be concerned if you did not do the same things in the same order. It's really okay. That's a tool. You just check to see if your answers are right. If your answers are right, then what you did is fine. If not, then you need to see if you can figure out what went wrong. All right, so to figure out what angle J is, we're going to do inverse sine of 12 over 17. If you happen to put it in upside down, your calculator is going to give you an error message because it's going to be too big anyway. All right, we get 44.9 degrees for J. All right, so then to find G, angle G, we're just going to do 90 minus 44.9, and we will get 45.1. All right, so for our word problem. All right, I don't want to write this whole word problem down, so I'm going to be a little lazy and do this. Here is our word problem. Ooh, focus. There it goes. All right, we have an engineer erects a 120-foot cellular phone tower. They want us to find the angle of elevation of the top to the top of the tower at a point on level ground 66 feet from its base. All right, so we have a tower. It's on level ground, so it makes a right angle. 66 feet from its base. We have an angle of elevation, so looking up to the top. That's what they want us to find, this guy right here. Alright, and we know that the cell phone tower is 120 feet. Alright, so we're looking for this angle. We know the opposite and the adjacent, so we can write a tangent equation. Tangent theta is 120 over 66. So to find that angle, we have to do inverse tangent of 120 over 66. So with your calculator, you'll do second tangent 120 divided by 66. So it'll look like that. And you get 61.2. We're going to assume that we're still going to go to the 10th place since our directions didn't say. Alright. So this next one, you're not going to be looking for an angle. They give you an angle. So if you want to pause and try it, it should be review of what you did like a week or so ago. Almost 2 weeks ago now. On that 41244 test. Alright, so this one says the sun is 20 degrees above the horizon. Find the length of the shadow cast by a park statue that's 12 feet tall. Alright, so the sun is up here shining down. The statue has to be in the sun's rays, like between you and the sun, for you to see a shadow. We assume that statues stand vertical, so to make a right angle with the ground. Okay, we know that the statue is 12 feet tall. We know that the sun is 20 degrees above the horizon. So if you're standing here, the angle of elevation to the top of the statue, because the sun is shining like this. Okay, so we assume that this is our angle. Alright, so now that you have the picture, see if you can write your trig equation and solve for the length of the shadow. Alright, so we have tangent again. We have opposite and adjacent. So we're going to say tangent of 20 degrees is opposite over adjacent. Remember we said if we're dividing by the variable, to get that variable off, we're going to multiply it over here and divide that. So these just switch. So we know x is equal to 12 divided by tangent of 20 degrees. And you just type that in your calculator. 12 divided by tangent of 20. And we get 32.97. So we're going to the nearest tenth. We probably want to round that all the way to 33, right? Alright, so your assignment is not very long. It's 8 questions. These first ones are they give you the triangle and you're solving, like numbers 1 through 3. These last 4 is going to be some like this. I think maybe 2 of each. If you have questions, if you need help drawing your pictures, whatever, just please let me know.